across a very interesting and a very beautiful sum based on trigonometrical ratios of complementary angles. Let's see the sum first. It says if A, B, C are the interior angles of triangle ABC, show that sine of B plus C upon 2 is equal to cos of A upon 2. Now this is what we need to prove, right? If you look at the two proof, and if you look at the left hand side and the right hand side, the angles which you have, if you look there, you see B, C and A. And what are A, B and C? They are angles of triangle ABC. So the next question is, what do we know about the sum of all angles of a triangle? We know one thing, that the sum is equal to 180 degree. That means we are saying that angle A plus angle B plus angle C is equal to 180 degree. Right? Isn't that easy till now? So that is the very first thing we understand from the sum. Now, when you look at the two proof, it says we want 2 in the denominator. So we want 2 in the denominator here. So for getting 2 in the denominator, we are going to divide the entire equation by 2. That means we'll divide the left hand side by 2 and also the right hand side by 2. Let's do that. So we'll get angle A plus angle B plus angle C, right? This expression upon 2 is equal to, on the right hand side we'll get divided by 2, right? So this is nothing but reason is dividing both sides by 2. Easy. Now you got A plus B plus C upon 2 on the left hand side here, and on the right hand side we have 180 upon 2. You know 180 upon 2 is nothing but when we do the cancellation we get the answer as 90. Now we are going to split the numerator. Why? Because we want only B plus C upon 2 to be separate. So let's do that. Now when you split the numerator, you'll get it as A upon 2, right? 1 plus B upon 2, right? Plus C upon 2 is equal to 90. But we want only B plus C upon 2 to be separate. So we'll keep only B and C terms on the left hand side and we'll take A onto the right hand side. Let's do that. So if we do that, we'll get B plus C upon 2 on the left hand side here, right? So B plus C upon 2 on the left hand side here. On the right hand side, we get 90 minus A upon 2. So ultimately, we get the value of B plus C upon 2 as 90 minus A upon 2. Now, we have not started proving it. Now, if you see the two proof, that the left hand side we have to consider. So, we are going to consider the left hand side. Left hand side is sine of B plus C upon 2, right? So, we consider that sine of B plus C upon 2. Now, if you see sine of B plus C upon 2, we have written, but what is the value of B plus C upon 2? Did we find it? Yes, we had just found it out and we got the value of that as 90 minus A upon 2, right? So, we get sine of 90 minus A upon 2. Now, observe that, right? We got sine of B plus C upon 2 is equal to sine of 90 minus A upon 2. Now that sine of 90 minus A upon 2, here we can apply trigonometrical ratios of complementary angles because it is in the form of sine 90 minus theta, where theta is A upon 2. And you know what? According to that trigonometrical ratios of complementary angles, we know sine theta is equal to cos, or rather sine 90 minus theta is equal to cos theta. That means here it will be cos of A upon 2. And we substitute that value here. And you know now that cos of A upon 2 is nothing but what? It is equal to the RHS. That means we have proved the left hand side equal to the right hand side. That means we'll get sine of B plus C upon 2 is equal to cos of A upon 2. And that is what we were supposed to prove in the sum. Wasn't that easy? A simple and interesting sum.